All right, lesson 2.6 is on proving geometric relationships. Okay, so we're going to be talking about angle relationships specifically in this section. In the upper left corner of your handout, I have what's called a flowchart proof. And then I also, in the upper right-hand corner, have a two-column proof. We're comfortable and familiar, at least, with the two-column proof. We want to look at a flowchart proof today. We'll also talk about what's called a paragraph proof. And I think that, to be honest, if I wrote the textbook, I would start you, if I was going to show you a flowchart proof, I'd start you with a flowchart proof first, and then move you into a two-column, because I think it makes more sense this way. Yes, Emmanuel. No, you can choose. I'm going to give you, since we did the most practice on two-column proofs, I'm going to give you the option to do a two-column proof. But if you would prefer, if you practice up the next two sections or next 2 days on a flowchart or on a paragraph proof and you prefer that, I will accept that as a valid proof. Okay? I think, honestly, well, I'm biased because I'm a teacher. It's easier to grade a two-column proof than it is a paragraph or a flowchart proof. And students don't typically like to draw the boxes to make the flowchart proof. But the arrows, I think, do help. Okay? So we're going to talk about how we are going to prove that angle EBA is congruent to angle CBD here using this flowchart proof. And then we'll translate it to a two-column so you can see the difference between them. Okay? So we're starting out with a given. Measure of angle 1 is equal to the measure of angle 3. So they've made those marks for us already. We had those two small angles equal to each other. Okay? Then they want us to prove that EBA, this angle I've highlighted or drawn in blue, is congruent to CBD. That they have the same measures. So we're trying to get to the blue one equal to the red one. Okay? So always in a two-column proof, doesn't change from a flowchart to a flowchart proof or a paragraph proof. What is always, always, always the first step in proving things? The given. Okay, so that makes sense then that they would start with this flowchart proof and say that we are given the measure of angle 1 equals the measure of angle 3. Just write the word given there. Okay. Now they left a blank asking you, why is EBA, the blue angle, equal to angle 2 plus angle 3? They add up to EBA. What's our postulate? What's the name of that postulate? Angle addition. Very good. Okay, that's our angle addition postulate. Then next they said, based on these two things, do you notice this arrow here? These two come together to be able to say this. So why can we say that EBA equals the measure of angle 2 plus the measure of angle 1? Good. So what's our actual, what's one word reason for that? What are we doing? Substitution. We're substituting. We're simply substituting 1 wherever we saw 3. Okay. Now they say, by using their arrow, that this thing is following from here. EAB is the first part. It's equal to 2 plus 1 here, but 1 plus 2 there. What says that we can do that? Reflexive, maybe. Transitive, maybe. Might be something with an S. Symmetric, okay. You're all on the right track. It's one that we didn't actually write down in our lesson 2-4 assignment or notes. It's like symmetric. We're switching to the order of things, right? But we're not actually switching the sides of the equal sign. We're actually changing the position of two things that are added to each other. And that's not one that I had you put on your sheet, so this is not one that you'll be responsible for on the test. But this is called the commutative property. Commutative property for addition. We used it back when we were first learning about addition. It says that we can change the order of addition problems and it doesn't hurt a thing. Okay? The next one is going to be, well, look here. We've got now a new line of thought coming in, not connected to anything else. And it's saying that the measure of angle 1 plus the measure of angle 2 is equal to this red angle, CBD. How can we say that? Angle addition postulate. Does everybody agree? Angle 1 plus angle 2 should be angle CBD. Two small angles make the third larger one. And it's okay to use that same postulate twice in the same proof. There's nothing wrong with that. Okay. Now they're saying because of this and what we had up here, we can make this conclusion. So let's look at those two guys. EAB equals 1 plus 2. 1 plus 2 equals CBD. So EAB equals CBD. Why? Transitive. Bingo. Perfect transitive, right? We have A equals B, B equals C, therefore A equals C. Okay. That's what a flowchart proof looks like. What do you think? Like it better? About the same? About the same. We're still doing the same thing, right? We're accomplishing the same thing. The arrows kind of help, I think. It says, hey, these two things go together to get this. Here's another thought. This is coming in, but these two come together to make that happen. Okay? So let's write that as a two-column proof now that we've worked our way through it. Always first step, given. That's points on your test. You can do nothing else. Don't leave those blank. Okay? You can do more than that, I'm sure. But that's always a start. Okay? Next step then, they said, well, let's do the measure of angle EBA is the measure of angle 2 plus the measure of angle 3. That is by angle addition. Then EBA is 2 plus 3. I'm sorry, 2 plus 1. By substitution. Then they wanted to just change the order and write measure of angle 1 before measure of angle 2. So by associative property, we can do that. And then next, they brought in the next thought of the measure of angle 1 plus the measure of angle 2 is the measure of angle CBD, that red angle. Angle addition again. And finally, what we were trying to get in the first place, EBD, is now equal to the measure of angle CBD. I'm sorry, EBA is congruent or equal to the measure of CBD by transitive. Okay, yes, sir. I will not count it wrong. Nope. You have to have angle addition, though. It's the most important pieces. Yes, there is. If we're adding up numbers, if we decide to add 5 to both sides, that would just be plain old addition. Okay? Addition property of equality. Okay. So, in your book, on page 106, you have some theorems. If you don't have your book, you can use your student journal. Page 61 of your student journal also has the same information. Okay? I want you to write down page 108 in a beige colored box. They have a theorem, theorem 2.3, right angle congruence theorem. I want you to write some notes straight from your book. What does the right angle congruence theorem say? Toward the top of your page on page 106 or page 61 in your student journal if you don't have your book. I think everybody's got their book today almost. Okay. What does the right angle congruence theorem say? T. All right angles are congruent. Okay, that's what I want you to write in that blank. If you want to abbreviate congruent by using the congruent sign, that's perfectly fine. Okay. All right angles are congruent. Right angle congruence theorem. The next one is your congruent supplements theorem. It is on the top of page 107. What does the congruent supplements theorem say? Okay. Supplements theorem says that if two angles are supplementary to the same angle or congruent angles, then they are congruent. What does supplementary mean? They add up to 180. So if two angles are supplementary to the same angle or to congruent angles, those angles have to be equal to each other. Okay? There's a drawing here. And they no, unfortunately. They'd be useful, wouldn't they? And the problem is that if all the geometry teachers aren't doing it, then it's not fair for you to be in one class and not another. I can talk to them about it. But we have to be consistent across the board. That way it's fair. Okay? All right, so this means that since 1 and 2 are supplementary, and 2 and 3 are supplementary, therefore 1 has to be congruent to angle 3. They're both supplementary to 2. They're congruent to each other. You wouldn't have to write the whole theorem out. You could just say congruent supplements theorem if you were proving something using that. Okay. In your book, right below the theorem 2.4 is theorem 2.5, and it's the congruence complement theorem. Brandon. It could be on your test. You could be needing to use that in order to prove things congruent. Okay, so congruent complements theorem says if two angles are complementary to the same angle or to congruent angles, then they're equal. Have equal measures, they're congruent. Remind me, what does complementary mean? Angles add up to 90 degrees. So in this example, 4 and 5 are complementary. And 5 and 6 are complementary. So 4 has to be congruent to 6 by the congruence complement theorem. Linear pair postulate. What does your linear pair postulate say? Top of page 108. Very good. If two angles form a linear pair, then they are supplementary. This is something from last chapter. Okay. Last chapter, they're just reminding us about it. We talked about it last chapter. If two angles form a linear pair, then they're supplementary. Remind me, what are a linear pair? So here's the same line, right? A linear pair are two angles formed by, they have a line for their non-congruent, or their non-adjacent sides and one adjacent side, right? One adjacent rays. So we have opposite rays with an adjacent ray, and their opposite rays are obviously opposite, forming a straight line. So these guys have to add up to 180 if they're supplementary. So angle 1 and angle 2 are supplementary, which means that the measure of angle 1 and the measure of angle 2 add up to 180. Okay? Last theorem. The last theorem, what does the vertical angle theorem say, Alex? On page 108 for the Milton book. Sorry. Go ahead, Derek. Vertical angles are congruent. It's an easy one to remember. Not much to it. So vertical angles. Vertical angles are congruent. What in the heck are vertical angles? Remind me. We defined it in chapter 1. Laura. Good. 2 and 4 in this example go together. Those two have the same measure. And 1 and 3 have the same measure. So if we're trying to think of vertical angles, somebody asks you, quick, draw two pairs of vertical angles for me. What are you going to draw? an x, okay? You're going to give me two lines, right, forming an x, okay? The vertical angles only share a vertex. They're formed by two pairs of opposite rays, and they only share a vertex. The only thing they have in common is that point where that x meets. Their angles are formed by rays that don't touch. They're not adjacent. Okay? All right. Now you can do some problems based on these theorems. So your first example on your sheet, for the middle right, we have the measure of angle 3 is 128. Okay? We're asked to find all the other measures. So mark it up. Write 128 here. Can someone tell me the measure of another angle? Laura? Good. Why is angle 1 128 degrees? They're congruent because what type of angles are they? Vertical angles. Vertical angles are congruent. So angle 1 is 128 degrees. Piper has an answer for me. How are we going to find angle 2? Oh, I thought you knew. Laura. Good. Laura noticed that we have a straight line here, don't we? So 1 and 2 are a linear pair, meaning that they will be supplementary. Good. If they're supplementary, then 2 has to be whatever 180 minus 128 is. And it's 52. This is why I want you to have a calculator. We've got enough going on with all the vocab that we're learning and all the relationships and the theorems that we're learning to not have to worry about addition and subtraction and multiplication anymore. So make sure you're bringing a calculator. Scientific is fine. Tell your parents you're worth $14 to get a scientific calculator. Your geometry grade will improve. Okay? So we're almost there. We still have angle 4 to figure out. Yes. Good. Another linear pair, right? So these guys have to add up to 180. And they're going to be congruent. 4 is congruent to 2 because they are congruent because they are vertical angles. So angle 4 also has to be 52 degrees. Okay? So you can work your way all the way around that figure. Good stuff. Okay? 2 more quick examples and I'll turn you over to a worksheet. No book work today. Okay? Find the value of x. All right, so Laura and Braxton have been on fire today. We've got to pick on some other people to make sure that they're helping us out. How are we going to do something with this? Which ones are going to be congruent? We don't know. Good. These are vertical angles, so this should also be 101, right? So what's an equation that we can write to make that make sense? Yeah, 4x minus 3 equals 101. Add 3 to 101. Divide by 4. And 4 goes into 10. Again, calculator would be great. 26 times. And that's what they asked us for, was the value of x. Made you do some proofs to be able to understand these things. Now we've got some theorems that we can work with, and because of these theorems, we can quickly work our way around these figures. You're going to get You'll get stuff like that on the test as well. And this is what most of what you're going to see from here on out in geometry is going to look like. We had to do a lot of foundational work with vocabulary and some theorems and proofs to get there, but a lot of it's going to look like this. So there's light at the end of the tunnel, and you guys can bring your grades up. Okay? I want everybody to bring their grade up. There's nobody with 100% right now. There is one person in my 5th hour class that has over 100% because she got the bonus points on that last test. Makes a difference. Being here helps. Okay, so here we go. One last example. Okay, now I want to show you a paragraph proof. And again, if this makes more sense to you, you're a writer and you're verbal and you'd rather do a paragraph proof than a 2-column proof, by all means, you can flip your paper over and write the paragraph proof on the back. Okay, doesn't have to be 2-column. So, write a paragraph proof. We're given that angle 1 is congruent to angle 4. I always, first step, start writing up my drawing. 1 is congruent to 4. Make that mark. 1 and 4 are congruent. Okay? We are supposed to prove that 2 is congruent to 3. So I don't make the mark saying that they are. That's what I'm trying to get to. Okay? Once I do enough statements to where those are marked, then we probably can get there by substitution or transitive or something like that. Okay? Nope, I'm not going to test you specifically for paragraph. If you want to use it in lieu of a 2-column proof, you can. But we had most of our practice on 2-column. So I'm not going to just one day before the test say, oh, by the way, I want you to do something you haven't practiced much. Okay? That's not how we work. Okay? So here we go. We're given angle 1 is congruent to angle 4. So what's the first step in every paragraph, flowchart, and 2-column proof? Given, right? The given. So we're given that angle 1 is congruent to angle 4. Just writing a narrative here. Okay? Well, let's work with that. 1 is also congruent to what? Angle 2. Why? Good job, Piper. Vertical angles are congruent. So angle 1 is congruent to angle 2 by vertical angle theorem. You can abbreviate in a paragraph proof. Can we use those two statements to write another relationship? If 1's congruent to 4 and 1's also congruent to 2. So let's go with 4 congruent to 2. Everybody okay with that? Okay. Angle 4 is congruent to angle 2 by substitution. Good. Okay. Getting closer. But what's 4 congruent to? Okay. And 3. Why is 4 congruent to 3? Vertical angle theorem? Are we there? Almost, but we have them marked, right? Now that they're marked, they should be congruent by substitution, transitive, something like that, right? We're trying to get to 2 congruent to 3. If 4 is congruent to 2 and 4 is also congruent to 3, left sides are congruent. That means, yep, 2 and 3 are congruent by substitution. Why is it not transitive? Yep, simply because of order. If it had been 2 congruent to 4 and 4 congruent to 3, then we could say 2 congruent to 3. But this is by transitive, but this is just plain old substitution. Okay? All right. Assignment is going to be a worksheet. These are some key ideas from last chapter that you have to remember and retain. We've been working with angle addition postulate, right? We have a segment addition postulate, and so forth. I'll put this up again tomorrow, but it may not be a bad idea for you to take your sheet that you've got and fold it in half and remind yourself what those things say. You could write those things down again to help you prepare for your test. Okay? You don't have to do it today, but that might be a good strategy for reviewing. Yes, I will be giving you a study guide for the chapter test. Chapter test is going to be on Thursday. So we're working on this today. We'll work on these kinds of problems again tomorrow. And then review on Wednesday, and then chapter test will be Thursday. So lots to talk about. These are, I think, the easier problems of it all, so it's nice to end the chapter with some easier stuff. And then we'll have a lot of vocabulary to make sure we remember. Okay. You're welcome. 4. You're welcome. I would like you to make one change for me. Number 8. I didn't catch it before I printed these. So number 8, I'd like you to change it so that it says the measure of angle 1 equals 8x minus 2. So change that from a 12 to a 2. And the measure of angle 2 equals 4x plus 14. That'll give you some nice numbers with no decimals when you work those out. Number 8. The measure of angle 1 equals 8x minus 2 instead of 8x minus 12. And then that second measure of angle 1 becomes measure of angle 2 equals 4x plus 14. Okay? All right. If you need to review this, I'm recording this for the blog. It'll be on my website. You just go to the geometry page, click on today. There'll be a video up there, so you can go back and watch. 1 second. Absolutely. Just a second.